Good morning, good evening, good afternoon. Welcome back to the channel. This is GED Math with Mr. Leo. Today's lesson is part 3 of our unit on circle geometry, which is an entry point into GED Math, starting in the middle for beginners. This video is designed to follow parts 1 and 2, so make sure you've seen those before, or you might be a little thrown off. All right, let's dive back in and let's keep going with some variations and extended techniques based on circle geometry. All right, so at this point, I'd like to add a new vocabulary word for you. The term is surface area. Surface area is the total area of all the outside surfaces of a 3D physical object. The surface area of a sphere is the total area of the surface of the object. How much would it take to cover this ball completely? If this was a basketball, how much rubber would you need to put the ball together? This is a rectangular solid, also known as a rectangular prism, also known as a box. The surface area of this would be the total area of all the surfaces, each side of this box. How much cardboard would it take to build the box? Surface area is a form of area, so surface area is always calculated in square units. Surface area can be used with any 3D object, just the way volume can. The way that we can find area and circumference of a circle, we can find volume and surface area of a sphere. Here is the new formula. SA equals 4 pi r squared. This is the formula for surface area of a sphere. Surface area equals 4 times pi times radius squared. Let's try this right here. Let's calculate the surface area of this sphere. Here's the formula, 4 pi r squared. Okay, now right away, I'll notice that we have a diameter of 14 centimeters. We're going to need the radius for this formula, so we're going to cut that in half and we're going to get a radius of 7 centimeters. Now let's write the full formula. SA equals 4 pi r squared. Let's plug in what we know. 4 is 4, pi is 3.14, and the radius is going to be 7 to the second power. That's it. Grab your calculator, type it in. 4 times 3.14 times 7 times 7. And I'm getting 615.44. This would be square centimeters, not cubic, because we're looking for the area that would cover the object. And area is always square units. Even surface area of a 3D object is square units. Does that make sense? All right, this is our answer. Good job. How do you feel about that formula? It is a goal of mine that when I'm done with you, you'll be able to use almost any formula, even if you've never seen it before, just by following these basic concepts. And here you go, 4 pi r squared. Maybe you've never done this before, but look, it's not that bad. At this point, I would like to show you some excellent materials that are developed by CUNY, the City University of New York, in their adult literacy program. They've got some great materials. I'll be linking to it in the description. I'd like to point out this page from their 3-dimensional geometry workbook, where they give you a visual proof of the formula. Check it out. Here is a tennis ball. That is a sphere. Now, the formula that we just looked at is that the surface area, what was it? Did you write it down? 4 pi r squared. You'll notice that pi r squared, that's just the area of a circle. So what they're saying is to cover the outside of this tennis ball, you could take 4 flat circles and put them together and it would work. So look right here. The idea is that, what if we took the tennis ball and you cut it in half? You would have these two right here. But look, these are not flat circles. These would be domes, right? This is going to be a curved dome. But that's where we're starting from. Cut the tennis ball in half, and I have 2 half tennis balls now. Let's go to the next page. Now imagine cutting up those two domes into small pieces and then laying those small pieces flat. As they cut up one dome, they get two flat circles worth of material. Then, as they cut up the other dome, it ends up being four flat circles worth of material. That full round tennis ball has become four flat circles. What do you think about that? That's where the formula comes from. The surface area is literally four circles, 4 pi r squareds. This is part of the universe itself. This is part of physical reality. Eh, Maybe you don't care, but maybe you're like me and you think this is kind of beautiful. This is something beautiful about physical reality that these relationships all play out so nicely. I'm going to leave a link to this whole packet. There is great stuff here for self-study. They've done a very thorough job, and I want to congratulate my friends at the City University of New York Adult Literacy Program for putting together so much fantastic material for this new technological age we're in. Some of these packets are like 100 pages, so if you can print them out, great, but they work really well if you're using a computer or even a tablet like an iPad or something. You can really open up these files and go through it right there. Great free materials. I'm going to put a link in the description and you can take a look at everything they have to offer. All right, so let's practice this right here. Here is a sphere. I'd like you to pause the video right now. And can you work out both of these things, the volume and the surface area? All right, are you ready? Let's go over this. You'll notice from the diagram, they've given us the radius is 22 yards. I'll do surface area first. It's the new one. We're going to write the original full formula. We're going to plug in what we know. We're going to go to the calculator. And I'm getting 6,079.04. I'm going to just round that off to the whole number, 6,079. That is the surface area. This would be square yards because surface area is a form of area and it's always square units. Volume, this should be pretty comfortable at this point, even though the formula is so complicated. Always start with the full formula. Plug in what you know. Now remember, writing this stuff out, it's not just to keep your work clean, it's also good practice. It's good habits. The more you write it out, the more it's going to stick in your brain. Don't be lazy. Write out all the steps. It's going to help so much. Let's grab our calculators here. Final answer here, I got 44,579. I'm going to round that up to 580. How do you feel about that? Do you see why I rounded it that way? This would be cubic yards. All right. So inside this sphere measures 22 yards as a radius. The diameter would be twice as much. So this is a large sphere. It's 44 yards across. That's pretty large. To cover this ball would take 6,000 square yards at least. And inside of it, you could put 44,000 cubic yards. Okay. How do you feel? Is it working? All right, let's move on. Here's a word problem for you. Here is the surface area formula. An official NBA basketball has a diameter of 9.5 inches. Can you calculate its surface area? What about the volume? Take a minute, try to work this out. You can pause the video if you want before I give the answer. All right, let's go over it. So diameter is 9.5. What's the first thing you got to do? Let's get the radius. Okay, radius is going to be that divided by 2. I cannot do that in my head, so I'm going to type it in. 9.5 divided by 2, 4.75. The radius of an NBA basketball is 4.75 inches. All right, here's the surface area formula. I'm going to write it one more time. 4 pi r squared. We're going to plug in what we know. 4 is 4. Pi is 3.14. Radius we determined was 4.75, and that's going to be to the second power. I'm going to grab the calculator. 4 times 3.14 times 4.75 to the second power, and I have 283.385. 283.385 square inches. That means to cover this basketball would take approximately 280 square inches of material to go around the outside of the basketball. We've also been asked the volume, so we can work that out quickly. 4/3 pi r to the third power. That's going to be 4/3 3.14, and the radius is what we sorted out, 4.75 to the third power. And I'm getting 448.69. I'm going to call that 448.7. It's up to you how you want to round it off. And this would be what? Cubic, because we're volume, cubic inches. Okay, so inside that basketball is almost 450 cubic inches of air. Okay, great. That's the surface area formula. How do you feel? You like it? Let's move on. All right, here's some word problems. Let's do these together. A sphere has a surface area of 50 square inches. How wide is it? Give your answer as an integer. Okay, integer means whole number, remember? So, what do we know? We know the surface area is 50. They're asking us how wide is it? What do they mean? Width. What's width? Width of a sphere, that is the diameter. We're being asked to find the diameter. All right, I believe we're going to have to work backwards. So let's start with the formula. Surface area of a sphere is 4 pi r squared. Let's plug in what we know. We know the surface area is 50. They're giving us the result. 50 equals 4 times 3.14 r squared. We're going to have to now get r by itself. Now, ultimately, we want diameter, but to get diameter, the radius will suffice. If we have the radius, we can easily get the diameter. So for now, we got to get this radius by itself. We got to remove all this stuff that's being done to it. And to do that, we got to do operations to the entire side. So let's start right here, get rid of that 4. We're going to divide that 4. This 4 is being used as a multiplier, so we're going to do the opposite operation, division, to remove it. If you do it over there, you better do it over here. This is going to cancel out these two 4s. So the left side is 50 divided by 4. I'm getting 12.5. That's my left side. And on the right side, what remains is 3.14 r squared. We're going to divide the 3.14 now. Make sure you do it to both sides. That will cancel out these over here. So the left side will be 12.5 divided by 3.14. I've got a long decimal here. I'm going to round it off to 3.98. Are you with me? Make sure you're doing this in your notebook and you're checking the work on your calculator as well. Okay, the left side is now r squared. So what do? We got to remove that second power. We're going to do that by square rooting both sides. We're going to square root the left side and we're going to square root the right side. That is going to cancel out the power and we'll be left with just radius on the right. On the left, I'm going to have to type in that square root. Do you remember how to do that? You might need to use the secondary function button. Make sure you can do that. And I'm getting 1.99 as the radius. Okay. Now, they say give your answer as an integer, as a whole number. So we can just make that 2. 1.99 is basically 2. So 2 is approximately the radius. Are we done? Careful. Final step. How wide is it? This is a question about diameter. So if the radius is 2, the diameter is going to be twice as much. The diameter is going to be 4 inches. This is our final answer. A sphere has a surface area of 50 square inches. How wide is it? It's 4 inches. This sphere measures 4 inches across, and its total surface area is 50 square inches. All right. I'm going to clear my screen, and we're going to try this question number 2. A spherical balloon holds approximately 200 cubic inches of air. What is its diameter? We're being asked to find the diameter. And what do we know? It holds approximately 200 cubic inches of air. So what are they referring to? The spherical balloon holds 200 cubic inches of air. That, my friends, is volume. Volume is the space inside an object. Volume is measured in cubic units. So the volume is 200. We're being asked to find the diameter. Once again, we're going to have to work backwards. We'll start with the original formula. V equals 4/3 pi r to the third power. Our goal is to get the diameter, but to get there, we're first going to have to get the radius. So radius is here in the formula, but we got to get rid of everything else to get there. What do we do? Okay, well, we know the volume is 200, so we're going to plug that in. We're going to start by removing the fraction. We do that by multiplying both sides by the opposite inverse fraction. Because it's 4/3, if we multiply by 3/4, it will cancel out. So we have 200 times 3/4. That's 200 times 3 divided by 4. That leaves us with 150. All right. We still have 3.14 times radius to the third power. All right, let's get rid of that 3.14 by dividing it out. We're going to divide both sides by 3.14. Excuse my handwriting, you see what's going on. I'm going to bring my answers up here. 150 divided by 3.14 is 47.77. This equals r to the third power. We now need to get rid of the third power. We're going to do that with a cube root, a third root. We're going to do that to both sides. Cube root both sides. So we're going to carefully type this in. I need the number 3 on the screen first. Then I do secondary function, and I hit that exponent button, the one that lets you type in different numbers. Because I did secondary function, it will create a root with the third in the pocket. That's a third root. Then I'm going to type in the number 447.77 under the symbol, and I'm going to hit enter. Gives me an answer of 3.628. You could round that off how you see fit. I'm going to keep it simple and just write that. That's what I see. And this is going to equal the radius. Okay, now remember, we wanted diameter. So to finish it, we're going to multiply it by 2. And I get my final answer. D equals 7.2568. I'm going to round that off to 7.3. 7.3 inches. You could have rounded it off a little differently. I'm doing this casually. For me, this is good enough. Okay, nicely done. Remember, you can always check that answer now by putting it back into the original equation. All right. Now, what I want to show you now is a new technique, a new way of dealing with pi that you're going to see on the GED and is seen in a lot of higher level math as well. This new technique is called answering in terms of pi. This method is used often in more advanced types of math, such as trigonometry and calculus, but it's on the GED as well. All you have to do to answer in terms of pi is to leave pi as the symbol. Do not convert it to 3.14 or any other approximated rounded number. All you got to do is leave the pi symbol in your answer. It actually makes things easier. Don't use 3.14. Just leave the symbol there. For example, this is a valid answer. 85.33 pi inches cubed. That could be a good answer. You notice that pi is sitting here in the answer. This is not considered incomplete. This is what they want sometimes. If you wanted to calculate this fully, you would have to take that 85.33 and multiply it with 3.14, and you would get the true answer. The answer is not 85. It's 85 times pi. It's going to be at least 3 times bigger, right? Because pi is a little more than 3. The reason for this is done to avoid approximating pi to keep it accurate. Every time that we use 3.14, we're actually rounding off the number. We're losing some information. If you just keep the pi symbol there, you stay completely accurate. This is also used to keep the math clean and organized as other things get even more complex and pi is used repeatedly within the math. Sometimes you do a lot of complicated stuff. You got pi all over the place. If you have to convert it to 3.14 every time, you're going to get a lot of decimals. You're going to have a lot of rounding off. Sometimes it's better if you just have 5 pi, 10 pi, 20 pi, 18 pi, and you just keep it like that. Complicated math can feel a little more simple and it's a little easier to work with. They do this all the time in trigonometry and calculus. So for now, I want to show this to you because it's actually a very easy technique for us to apply, and you're going to see it on the GED. This also falls into the category of algebra. Okay, here we go. Calculate circumference and area in terms of pi. So what do we know? Looks like the diameter is 8, meaning the radius is 4. Watch how quickly I do this. Circumference. Well, since I have diameter, I'm going to use the diameter version. C equals pi times diameter. You ready? We're almost done. Okay. What do you do with pi? I told you, leave it alone. In terms of pi means leave the symbol alone. The diameter is what? It's 8. All you got to do to finish this is put it in standard form. Standard form is you put the number first and the pi symbol last. The circumference of this circle is 8 pi. We're done. I guess you could say 8 pi feet. That's right, it's 8 pi feet. Please notice though, the circumference is not 8 feet. It's 8 times pi feet. This would actually be closer to like 25. It'd be like 3 times as much. But this is a valid answer. See how quickly and cleanly we did that? I love it. All right, we're gonna do the area. Area is pi r squared. All right, pi, we're gonna keep it as pi. Don't use 3.14. Radius in this case is 4. That's gonna be 4 to the second power. All right, what is 4 to the second power? That's 16. You're gonna rewrite this as 16 pi, and we're done. That's it. I guess we should say square feet to be thorough. The area of this circle is 16 pi square feet. Look at that. That is a valid answer. Okay, let's look at some more. Here we go. Answering in terms of pi. What is the volume of the container below in terms of pi inches cubed? If you want, take a minute, pause this video, and try to work this out on your own in your notebook. Okay, did you get a chance to work it out? Let's check our answers here. Okay, what do we know about this? It looks like the diameter is 4 inches. The diameter is 4 inches. The radius is going to be 2. They're asking about volume. Let's write the formula. 4/3 pi radius to the third power. Now, notice they say in terms of pi inches cubed, cubic inches, because it's volume, in terms of pi. You notice all these answer choices have a pi in the answer. Okay. So that means we're going to leave pi alone. We're still going to do 4 divided by 3. I'm going to just move pi to the end. Radius cubed, that's going to be 2 to the third power. We're going to do all the numbers, and we're just going to leave the pi alone. So I'm going to grab my calculator. Basically, what I'm going to type in is 4 divided by 3 times 2 times 2 times 2. All right, 3 instances of the 2 because it's the third power from the formula. I got 10.666666667. We can round that off to something. Looking at these answer choices, let's choose 10.67. Don't forget the pi. You have to include the pi in your answer for it to be complete. Units are cubic inches because that's what we were asked. All right. There you go. You can clearly see the answer is B. How do you feel about that? Answering in terms of pi. All right. Let's move on. What is the surface area of this sphere in terms of pi? Take a minute, try to work this out. I'll give you the formula. Surface area of a sphere is 4 pi r squared. You should have it in your notes at this point. Okay. Take a minute, work it out. All right, you got an answer? Let's check the work right here. Looks like diameter is 4. That means radius is 2. All right, so let's plug in what we know. 4 is 4. Pi we're going to leave alone because of this phrase in terms of pi. Radius squared is going to be 2 to the second power. So let's just do all the math that we can. Let's put all those numbers together and move pi to the back. I got 4 here, and I got 2 squared here. 2 to the second power. Pi is at the end. All right. 2 to the second power is 2 times 2. That is 4. This is essentially 4 times 4, pi. 4 times 4 is 16. Final answer here is 16 pi. We would still include the units. That is going to be square inches because it's surface area. Answering in terms of pi. That's it. Do you like it? I love this stuff. I love this one. So clean, so simple. It looks like algebra. This is what the professionals do. All right, here's a challenge I want to give you now. We're going deep on circles. Here is a semicircle. I'm going to read it. Below is a semicircle, which means half of a circle. There is no official area or circumference formula for a semicircle. But by using logic and reasoning and the basic circle formulas we've studied, we can calculate both. This comes up on the GED test. Here we go. Calculate both area and perimeter, meaning the circumference of the figure shown below. Meaning, what's the area inside the shape? That's one answer. And what's the distance around the shape? I use the word perimeter as well as circumference because circumference is for a true circle. It's not a true circle, so perimeter is actually a better word to describe the outside of the shape. So what do we have to do? What formulas could be used? What makes this different? Can you figure it out? You will see stuff like this on the test. There's no semicircle formula. You have to use the regular formulas in your mind. Let's start with area. Any ideas? Can you just describe in words what we got to do? Let's find area of a full circle and then cut it in half. This is the key. Don't start by cutting things in half. I know you want to cut things in half because you're smart. Don't cut that 10 in half unless you really want to. Let's find the total area as if it was a full circle. Then let's break it down. Okay, so what do we know? If this was a full circle, they would be showing us the diameter of 10. So yeah, I'm going to cut it in half, but let's just do that to get the radius. The radius would be 5 centimeters. Let's find the area of the full circle and then divide by 2. That's going to be pi r squared. What do you want to do? Do you want to do it in terms of pi or do you want to get a decimal? We'll do a decimal for now. Feel free as a challenge, try this in terms of pi, see if anything happens. Okay, it's going to be 5 squared. All right. I go to my calculator. I get 78.5. Okay, this is the full circle area. Full area equals 78.5. It's a good idea to take a little note just so you can be clear. If you're looking over this later, what are we talking about? This is the full area of a full circle. So the semicircle area is going to be half as much. All you got to do to find half is divide by 2. I use the calculator, of course, and I get 39.25. Area is 39.25 square centimeters. All right. You like that? They love doing stuff like this on the test, where they base it on the basic formulas, but you still have to use your own reasoning to get the answer. Okay, now let's do the same thing, but we'll find the outside of the shape, the distance around the shape, the perimeter. I'm going to clear my screen. The distance around a circle is the circumference. So we're going to base this on the circumference formula. I'm going to use my favorite, the revised version, C equals pi times diameter. Let's plug in what we know. C equals 3.14 times the diameter D, which is 10 in this case. Do a little math on that. We're going to get circumference equals 31.4. Now I need you to visualize this. That is a full circle. Now we want the semicircle. We want this shape. So we take this and then we divide it by 2 and we're left with this. So let's do that. This is the full circle circumference. So now we'll do the half circumference is going to equal 31.4 divided by 2. I get 15.7. So that's going to be 15.7. Now here is the big deal. Some people love to stop right here, say that's the answer. But are we really done? We want the outside of this shape. Now, if you look at it, how many sides does this semicircle have? It's got 2 sides. It has a straight side indicated as 10 centimeters, and it has the curve. We just found the curve. We found a full circle and cut it in half, and we got 15.7. That's the hard part. But don't stop here. They love to put 15.7 in the answer to trick people. We're not done. If I want the full perimeter, we've got to include this side along the bottom. If this diagram is showing, I don't know, a cage for your goats, if you don't put that side on the bottom, your goats are all running free. They're all going to take off. You got to close the fence, close the gate. Now, the good news is they gave us that number. It's 10. So to find the final answer here, I'm going to call it really the perimeter because it's the outside of the shape. It's not a true circle anymore. You just add up the sides. The curve is 15.7 and the straight side along the bottom is 10. Final answer here, 25.7. I guess it's centimeters. If it was goats, if it was my goat pen, it'd have to be feet or yards. Okay, guys? But you get the idea. All right, that's a semicircle. This is just one example of an unusual shape you might see on the GED. Instead of a rectangle, sometimes they give you an L shape. Instead of a full circle, maybe they give you a semicircle. Just take your time, visualize it, and apply the basic formulas. Nice job. All right, here's another one. Can you work this out? Take a minute, pause the video, work this out, and then take a look at the optional challenge. Give your answer also in terms of pi. All right, you ready? Let's work this out here. Okay, what is the perimeter of the window? Well, I would say the radius is 14 inches. We can see it's a semicircle. The diameter will be twice as much, that's 28. And I'm going to go ahead and just do the challenge. Give your answer in terms of pi. Okay, so altogether, this is a half circumference and a straight side. Perimeter equals 1/2 circumference plus 28. You see how I got the 28? It's 28 across the bottom. Circumference is going to be pi times diameter. Pi times diameter plus the 28. See how I'm keeping the plus 28 there? All right. Let's bring this over here. So I'm going to answer in terms of pi. So I'm going to leave the pi alone. 1/2. The diameter is 28. And I'm going to keep adding that plus 28 at the end to indicate the straight side. This is the curve. And this, I'm going to call it the base. This is the base along the bottom. So here we go. In terms of pi, I've got this expression here. Basically, you just want to move the pi to the back of this term. So it's actually going to be 1/2 times 28 times pi. And I'm just going to keep on bringing that base down at the end. We could have just done this at the end, but I'm going to keep it nice and complete. So we do a little math here. What is 1/2 times 28? You can think of that as just dividing by 2. 28 divided by 2 is 14. 14 pi plus 28. And this is our final answer. We could say inches, right? Perimeter, distance around, it'll be regular inches. This is a complete final answer. Take a look at this. Does this look familiar? Does this look like the GED? They love to do this. As a matter of fact, I love to do it too. Look how clean that is. I don't have any decimals. I didn't round anything off. The perimeter of this figure is 14 pi plus 28 inches. That's it. So clean, so nice in terms of pi. Now, if you want to work out the actual decimal answer, you could just substitute pi here. So let me clear a little bit over here just to make some space. If we wanted to check this answer or get the other version, the full worked out version, you'd say 14 times pi. Now I'm going to use the 3.14 plus 28. Calculator, 14 times 3.14 plus 28, and I'm getting 71.96. This is equal to 71.96 inches. And there you go. That's it. Two versions of the same answer. Both are valid. But you can see why this one is kind of nice. And they would love to ask this on the GED. If you can understand this version, that means you really understand the language. You really understand the formulas and the language of algebra and geometry. I hope that makes sense to you guys. Okay, we're doing great. Let's move on. To close this out, I have a bonus lesson. Let's explore this fraction, 22/7. Have you seen this before? It's not a huge deal, but it comes up sometimes in the context of circle geometry. Sometimes you may see where they write, use 22/7 for pi. Have you ever seen this before? Every once in a while, you see this. Use 22/7 for pi. But why? Why do they say this? I'm going to show you. What are all the different ways we can write this fraction? Can you break it down? What does this actually have to do with circles? Okay, well, here we go. 22/7 means 22 sevenths. This means if you know a little about fractions, it's 7 sevenths plus another 7 plus another 7, and then 1 left over. 3 sevenths is 21, 1 left over makes 22. Every 7/7 is like a whole. So really, this is 3 wholes and 1/7. If you know about changing fractions to mixed numbers, this is an improper fraction to a mixed number. 22/7 is equivalent to 3 and 1/7. Also, if you grab a calculator, you divide it, 22 divided by 7, you get a long decimal that looks like 3.1428. What's the big deal? Well, look, 3.14. So this is approximately pi. Now, if you really notice, it's not the same decimal as pi. It's a little different. But it's got the 3.14. So that's very close. And we love to approximate pi. We're always rounding off pi anyways. So this is the reason. 22/7 is another variation of an approximation for pi. You can use this fraction instead of pi. Now, why do you want to do that? This fraction 22/7 is sometimes used as an approximation for pi. Well, trust me, they're not doing this to make things more complicated. It might seem from our perspective that this is more complicated. Why are you throwing this weird fraction at me now? This is not helping. You're not making it easier. I get it. I get it. But the big picture is there are time and places when this actually does make things simple. Only certain occasions. As we discussed, this fraction is equivalent to very close to 3.14. And remember, 3.14 is also an approximation. That's been rounded off. The true pi is a never-ending, non-repeating, irrational decimal. So we're rounding off anyways. Why is this useful? Because sometimes using 22/7 instead of 3.14 will make the answers cleaner and simpler, especially if there is a 7 somewhere in the math. That's it. If there's a 7 or a multiple of 7 in the math. Often, if there is, the 7 in the denominator of the fraction, right, the bottom of the fraction, this 7 can be canceled out with a 7 somewhere else in the math, leaving a cleaner answer than if we use 3.14. Again, it's just to make certain things cleaner. If your math involves 7s and pi, this allows them to cancel out and we can have some nice friendly whole numbers. That's it. Please note, this technique is completely optional unless directed. Sometimes they say use 22/7 and then you got to use it. Let's experiment a little bit with this and explore it and get comfortable. Let's try it. This circle has a radius of 7 centimeters. Calculate the circumference and the area. Okay, radius is 7, diameter is 14. Let's start with circumference. Since they gave us radius, I'll use the radius version. C equals 2 pi r. Let's plug in what we know. 2 is 2. Pi, what is pi? Right now, today, we're using 22/7. Okay, I'll put that in parentheses. And our radius is 7. Did I do that right? 2 is 2. Pi is this new variation, this new fraction, 22/7. Radius is 7. Here's the point. I don't even need a calculator. The 7 on the bottom cancels with this 7. We're left with 2 times 22. In the head, that's 44. I'm done. 44 centimeters. Look at that. No calculator. How about the area? Area is pi r squared. Let's plug in what we know. We're going to use this new variation because of the 7, 22/7, or maybe because you're instructed to. 22/7, that is our new variation for pi. Radius squared is going to be 7 to the second power. I'm going to write it out this way. 7 times 7. In this case, it's a good idea to write it out because you can't cancel it if it has a second power on it. You got to break it down. So I'm going to break it down first. I'm going to write it out, extended. Radius squared, 7 times 7. Now, the canceling part. Please notice that 1 7, this 7 on the bottom, will cancel with one of the 7s. That's it. The other 7 is going to remain in the answer. So now I have 22 times 7. I can't quite do that in my head, but you'd have to agree it's a simpler calculation than using a decimal. So 22 times 7, answer is 154. 154 square centimeters. All right, that's the purpose of this 22/7 business. It's an optional technique, but it has its purposes as an alternative approximation for pi. It's not the most important thing, but I want you to be comfortable because if you see it, I don't want it to ruin your day. Here's another example when you can use it. Let's try it. Circle has a radius of 14 centimeters. Calculate circumference and area. Circumference is 2 pi r. Circumference is going to be 2. Let's use this new variation, 22/7. And the radius is 14. Now, if you're really good with math and algebra, you maybe can just work this out right now. But even if you're not super confident, maybe I just want to grab my calculator. This is going to be 2 times 22 divided by 7. Remember, every fraction is a division. There's other ways to type it in, but this works. Let's just grab the calculator. 2 times 22 divided by 7 times 14. I got 88. Nice friendly whole number. This is the purpose. This is the reason for this variation. It sometimes gives you friendly whole number answers. All right. How about area? Area is pi r squared. So we'll use that variation And the reason we're using the variation is because they told us. But if you're really ahead of the game, if you notice this 14 is a multiple of 7, that's where it helps out. If that number is not a multiple of 7, this technique is really not going to help you. It's just going to make things weird. I'm pretty sure though on the GED and whatnot, when they want you to do this, they tell you to use it. So, okay, we're going to do radius squared. I'm going to write it out 2 times just to be safe. There's my 14 times 14. And now let's go to the calculator. Remember that fraction, you can just treat it as a division if you want. So this is what I want to get on the screen. 22 divided by 7 times 14 times 14. I got 616 as my answer. It's an integer. It's a whole number. That's the reason. That's going to be square centimeters because it's an area. Okay. 22 over 7 for pi, a somewhat useful variation that you might see every once in a while. If you see it, just use it. Treat it like a fraction. Every fraction's a division. If you see some canceling, take the canceling. If you don't see the canceling, you just use your calculator and you should get an answer anyways. The idea is it should make the answers a little friendlier. All right, great job. We've done a lot with circles. All right, that is it for this series on circle geometry as an introduction to GED math, starting in the middle, GED math for beginners. I hope you enjoyed this. I've got a lot more planned for you. We're going to do a little more geometry, then we're going to move directly into algebra and functions. Please subscribe to the channel for more free video lessons. Let me know what you want to see covered in the channel. Leave a comment. If you like what you saw today, please consider sending this video to someone else who might benefit from the lesson. It's word of mouth recommendations like that that really help keep the channel growing. Lastly, check out the CUNY workbooks on three-dimensional geometry that I took a few screens from. I'll put a link in the description. You can download them for free and you can view them on your device. They read very easily on screen. You can also print them out, but I caution you, they're about 100 pages if you print them out. That's a lot of paper. Feel free to do so. I'll also put a link to all the topics that the CUNY Adult Literacy Department has made available online. They've got workbooks on everything, every aspect of math on the GED, but also the other subjects as well. They've got a ton of information, great stuff there. If you can go through it on your own, feel free to peruse that and download whatever you're interested in, whatever you might need help with. I'll put a link below. They got great stuff for us. I appreciate those guys a lot for producing so much great material available to the adult education community. That's me. That's you. Anyways, thanks so much, guys. I'll see you next time.